Okay, we're going to jump ahead here to problem number 21 on page 194. I skipped over number 20. I will come back to that later, but I wanted to get to this ladder problem. Another classic example of a related rate problem. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when the base of the ladder is 7, 15, and 24 feet from the wall? And I'm really only going to go over this 7 feet from the wall because after that, it's just plugging in different numeric values and recalculating the solution. So first thing we want to notice is that we have a right triangle here. And so we're going to use the equation x squared plus y squared equals L squared. And the reason we're doing that is because we are talking about, in this problem, how the lengths of the sides of a right triangle are changing. And the lengths of the sides of a right triangle are related by the Pythagorean theorem. I've used the base down here as x and the vertical as y, and the hypotenuse here as L, as in ladder. We're given that the base is being pulled away at 2 feet per second. So at 2 feet per second is going to be a positive value, positive 2 feet per second, because if you think about it, the x dimension of this triangle, as this bottom moves away, the x dimension is going to get larger. When we get a final solution, the dy dt, this movement down the wall, well, the y dimension should be getting smaller. So we should get a negative result as our final answer here. Excuse me. We're going to focus on the first one, 7 feet. X equals 7 feet, and it's important to note that that's a changing dimension because as this ladder moves, x gets bigger. L, the hypotenuse, is 25 feet, and that's a constant. And they're asking us to find dy dt. How fast is the ladder sliding down the wall? So first thing I've gone and done is use the Pythagorean theorem, my x squared plus my y squared equals my hypotenuse squared, and solve to find out if x is going to be 7 feet, how much is the y value going to be? And that's a Pythagorean triple. It works out to a whole number. We get y equals 24 feet. And again, that is a dimension that is changing. So we do want to note that that's a changing dimension. All right, so we are going to take the derivative of our Pythagorean theorem. We'll start by bumping up our size here to a bigger equation size. New equation. We're going to take the derivative of our Pythagorean theorem, x squared plus y squared equals 25 squared. And the first question someone will ask is, well, why did you plug in 25, but you didn't plug in the 7 or the 24? And the answer is because there's a big difference between the 7, the 24, and the 25. The 25 is constant. It won't have a rate of change. The 25 is not changing ever. So anything that's not changing, we can plug into our equation before we take the derivative. Because we take the derivative of a constant value, 25 squared is 625, the derivative of that constant will be 0. We don't need a rate of change for that. So when we go ahead and take this derivative, we should get 2x dx over dt plus 2y dy over dt equals 0. Mathematically speaking, if I was to do anything here, I would factor out a 2, divide both sides of the equation by 2, and 0 divided by 2 is still going to be 0. So my equation is going to be x dx dt plus y dy dt equals 0. And at this point, we have an x value of 7 to plug in. We've got a y value of 24 to plug in. we've got a dx dt to plug in. We're going to plug in all of those values, and we're going to solve for dy dt. So x is 7 feet times the fraction, or times our dx dt was 2 feet per second, 2 feet per second, plus our y value is 24 feet times our unknown dy over dt equal to 0. We're going to simplify that now. That's going to give us 14 feet squared per second plus 24 feet dy dt we're going to go ahead and subtract this first term over to the other side of the equation. It's going to leave us with 24 feet. Equation, 24 feet dy dt equals negative 14 feet squared per second and our last step then is going to be a division. We're going to divide the 24 feet to the other side. Feet squared divided by feet, one of those is going to cancel. And we're going to be left with our solution, dy over dt equals 14 over 24 will both reduce by 2. This is going to give me negative 7. We're going to want to do a fraction here. Negative fraction 7 over 12 feet per second. And that's going to be our final solution. So very simply, we don't have to do much else with this. Negative 7/12 feet per second. Again, they gave you other values here, 15 and 24. All that's really going to do is it's going to change your x and y values as you plug them in. In fact, when x becomes 24, y, because of the Pythagorean triple, will be 7. So you just be reversing where you're plugging in the 24 and the 7. 15, 25, that's also going to be some Pythagorean triple, 3, 4, 5 triangle. So you should get y equals 20 for that one. So a pretty straightforward problem. There's a part B and a part C to this. Part B talks about how the area is changing, and part C talks about how a angle somewhere in the triangle is changing. And I'll do separate short videos for that, so we could do them as shorter videos instead of one very long one. So thanks a lot for tuning in.